This is question 64 of Civil Engineering paper General Aptitude section of GATE 2012. Which of the following assertion are correct? Assertion P. Adding 7 to each entry in a list adds 7 to the mean of the list. Assertion Q. Adding 7 to each entry in a list adds 7 to the standard deviation of the list. Assertion R. Doubling each entry in a list doubles the mean of the list. And assertion S. Doubling each entry in a list leaves the standard deviation of the list unchanged. So, in this question, 4 statements given, we need to select which statements are correct. So, let us check each statement given in the assertion one by one. In assertion P, it is given adding 7 to each entry in a list adds 7 to the mean of the list. So, for a set of numbers, we know the mean can be found as suppose the number are x1, x2, x3 up to xn. So, we can find the mean as x1 plus x2 plus x3 plus dot dot plus up to xn divided by total number of numbers in the sets, which is n. So, this is the formula to find the mean. Now, if we add 7 to each entry, then we can find the new mean. The new mean will be if we add 7 to each entry. So, x1 plus 7 plus x2 plus 7 plus x3 plus 7 and up to the value xn plus 7 divided by total number of numbers in the sets, which is same as n. So, we can write this equation as this. If we take this 7 as common, so 7 is repeated how many times? N number of times. So, we can write 7 into n plus x1 plus x2 plus x3 up to xn divided by total number of this n, total number of numbers. So, if we can write this 7 n by n is 7 plus x1 plus x2 plus x3 up to xn divided by n. So, this is what? This is nothing but the initial mean. So, we can write as 7 plus mean. So, from here we got, if we add 7 to each entry in a list, then we got the same increment, that is the mean will be increased by 7 only. So, this statement is correct. Now, the next statement is adding 7 to each entry in a list adds 7 to the standard deviation of the list. So, a standard deviation can be found by the formula. We know root over summation of this xi minus x mean to the power 2 divided by n, where I varies from 1 to n. So, if we add 7 to each entry, then we can write new standard deviation. New standard deviation will be root over the summation xi plus 7 minus this new mean. So, we know if we add 7 to each entry, the mean will also be increased by 7. So, x mean plus 7 and this is a square by the number n. So, from here we got this 7 and 7 will be cancelled out, 7 and 7 minus. So, we get the same result. Xi minus xn square divided by n. So, from this result we can say that if we add any number of if we add 7 to each entry in a list, then the standard deviation will remain unchanged. This is the new standard deviation is same as earlier. So we can say if we add 7 to each entry in a list, then a standard deviation will be remain unchanged. So this statement is wrong, as it is written adding 7 to each entry in a list, add 7 to the standard deviation of the list. No, the standard deviation becomes unchanged or remain unchanged. So this statement is incorrect. Now the next statement is doubling each entry in a list doubles the mean of the list. So check. So the mean, as we know, mean is x1 plus x2 plus x3 up to xn. It is nothing but the average of the numbers. So if we doubling each entry, so the new mean is 2x1 plus 2x2 plus 2x3 and up to 2xn divided by the number in the set which is n. So if we take 2 as a common, so we can write x1 plus x2 plus x3 up to xn divided by n, number of the n. So from here we can write this as a 2 into, this is nothing but the earlier mean. So 2 into mean. So from here we observe, if we multiply each entry with a particular number, then mean will be multiplied by with the same number. So here doubling each entry in a list doubles the mean of the list. Yes. So this statement given in assertion R is also correct. Now check the last assertion, which is doubling each entry in a list leaves the standard deviation of the list unchanged. So first write the formula for a standard deviation. A standard deviation which is root over summation xi minus this mean square divided by n. So new standard deviation, we can write, new standard deviation is, we can write the summation of doubling each entry. So 2xi minus, so if we double the each entry, then the mean will also double. So we can write 2x mean a square by n. So from here we can write this. If we take this 2 as a common, so 2, if we take 2 as a common, so 2 square will here. So 2 square summation, we can write this summation into xi minus x mean a square by n into 4. So if we this take out this 4s, so this will be 2 into summation xi minus x mean a square by n. So from here we observed that if we double the each entry in a list, then the standard deviation will also be doubled. So here in the statement is given, doubling each entry in a list leaves the standard deviation of the list unchanged. No. Why? Because we observed that the standard deviation will also be doubled. So the statement given in assertion S is incorrect. So here we got only a statement assertion R and P is correct. So R and P is given in option C. So we can say the P and R assertion is correct with respect to this mean and standard deviation here. So which is given in option C. So option C is the correct answer for this question. Thank you.